Yes, Assalamu alaikum. Can you hear me?
Yes, I can hear you. You are a bit late.
Yes, I had lost the link, so I was finding it.
Oh, acha. But you could have and when it happens, you can ask me. And we were doing kinematics. And can you update what you are doing? What are the plans to now? The April is moving on.
I was attempting like one paper. I found it really challenging as compared to the other ones. I can tell you the code for it, like in the chat.
Okay, was it a new paper or old paper?
It was, I think, February, March of the last year.
Acha. Maybe that paper, maybe this is possible. Sometimes some papers are over hard. And are you doing some topical work also, or you are doing for all subjects? Are you doing yearly only now?
Only for physics, I am doing topical a bit. For the rest, I am doing yearly.
So for other, you have started yearly only.
Yes.
And what about the topic notes revision and something like that? Are you keeping it with you, the work on notes?
For physics, where I find it challenging, I like play a video for the subject and then I try to understand from there.
Okay, good. And you know that you can find for every chapter I have a revision video. I think you know that, right?
Yes.
And I have it's on my channel. For every chapter there is a separate quick video that can revise the chapter. We had started kinematics in our classes, and we did some questions. This is November 12, 231. So you can note down the year, and this is 23 November 12, 2031. First thing comes, define power. So what is the definition of power?
Rate of doing work.
Rate of doing work. Good. Rate of transfer of energy, or rate of doing work. So that's perfectly fine. A cyclist travels along a horizontal road. The variation with time of speed v is shown. This is a velocity time graph. The cyclist maintains a constant power, and after some time reaches a constant speed of 12. Describe and explain the motion of the cyclist.
First, like we will say, it is accelerating at a decreasing rate.
Describe and explain the motion of the cyclist. He himself says that maintains a constant power and after some time reaches a constant speed of 12. This is something to see. He has not gone beyond 12, but his graph is still below 12. It means that this graph is not covering the constant speed. The constant speed is 12. So you can see here, this is 12. So this is still to reach. Now, describe and explain motion of the cyclist. Again, remember that we had made some sketches, and sketches are very, very important. So till the sketch is shown here, can you tell me the gradient is increasing or decreasing? The graph is getting flatter.
So the gradient is decreasing.
Good. Gradient is decreasing and gradient is acceleration. Am I right? Velocity time graph. For velocity time graph, gradient is acceleration, right?
For the velocity time graph. And for the displacement time, it was the velocity.
Yeah, it's a velocity time graph, right? So gradient is acceleration. So first thing we have noticed from the graph that gradient is decreasing, which means acceleration is decreasing. So we can say that gradient is decreasing, acceleration is decreasing. It's a 3-mark question. Now, what about velocity? Can you see that overall velocity is increasing?
But at a decreasing rate.
Yes. velocity is increasing at a decreasing rate until it becomes constant. Until it becomes constant. When the cyclist is moving at a constant speed of 12, the resistive force is 48 Newton. Up now, you have to see the formula for power. Power is equal to F into V. Do you remember that I had sent you a revision handout?
For the kinematics,
No,
where
for the whole syllabus.
yes, the 66 page one, yes.
Yes, that contains formulas, notes, and a lot of good things. Ideally, as I said, you should try to get it printed, and then you can use it because this is the final month. So a quick revision handout is very helpful. Now, power is equal to FV. The constant speed is 12, and the resistive force is 48. When the speed is constant, is it right that resistive force equals the driving force? If this is the resistive force and this is the driving force. So when speed becomes constant, the two forces will be equal, because when speed becomes constant, as he says, acceleration is equal to 0. And when 0 acceleration is there, resultant force is equal to 0. At this point, driving force is equal to resistive force. I'm making it clear because in this formula, P is equal to FV. In this formula, F means driving force. So velocity is 12. So can you do the calculation?
It is coming as 576.
It's coming as 576. Then why he is giving 600? You know the game of,
Okay, one significant figure.
yes. So in paper, you will have to mention this. Use figure 3.1 to show that the acceleration of the cyclist when this speed is 8 is about 0.5 meter per second. Now we know the power and we have the resistive force equal to the driving force. Now he says use figure 3.1. Speed is 8. So this is the diagram, and
So we'll take the gradient for this.
yes,
Till
we
it,
can reach this point. First, we reach this point. There are two possible ways to solve such a question. Ideally, you are right that we should draw a tangent, which is the best way. And second approach, which is not good, is read the speed and divide. But examiner is giving 2 marks. So it means we can take the chance of drawing a tangent because it needs some working. When you draw a tangent, you should always try to extend it so that it can touch the graph. The main problem when examiners check the tangent is that they always want that it touches the right. Now, this number is velocity. Now, this is the new sketch. I have updated it. And now you can read the numbers again. Now, we have drawn it again, and it's going up to 12. This one is 12. This is 4 point. This is 5. Now, can you read this for me? How much is this? 14. 14 to 16, the gap is.
This is almost 15.4, like.
But we can figure it out accurately also, that how we do that. We can see, look, 14.
Counting the boxes and then dividing the
Yes.
two numbers.
So the gap is 2. The gap is 2, and there are 5 boxes. So 2 upon 5, 0.4. And there are 3 boxes. So it means
15.2.
15.2. Right. The final value. So it means it would be.
Now the right answer is coming, I think, 0.4605.
This is an overlooking issue. So it's coming 15.2. So if we put this here, now it is 12 minus 5. And it is 15.2 minus 0.
It's coming as 0.47.
Right. Now, this was an example of a overlooking error that I took it at 8. The total mass of the cyclist and bicycle is 80 kg. Calculate the resistive force acting on the cyclist when his speed is 8. So we know the acceleration, and he says calculate the resistive force. So when the cyclist is traveling, suppose as a box, this is the cyclist is traveling, this is the driving force, and let's say this is the resistive force. He says calculate the resistive force when the bicycle, when his speed is 8. So we have the acceleration, but what is the driving force at this point? Acceleration, the formula is there. Resultant force is equal to ma. And we have the data.
We'll use this F is equal ma formula and then find the answer.
Because he's asking for the result. He's asking for the cyclist and bicycle. The total mass is 80. Resistive force R. Resistive force is there, which is opposing it. So this is the direction of acceleration.
Resultant force will then come as 14 Newton.
No. Resultant force we do not know. We do not know the resultant force, but can you tell me what is X? What I am showing as X, what is X?
The driving force.
Very good. It is the driving force. In this chapter, the formula for driving force, F is equal to PV. So this is the formula for driving force. Sorry. Driving force is P is equal to FV. F is equal to P upon V. This is the driving force. So resultant force will be X minus R is equal to MA. I am replacing the driving force by P upon V minus R is equal to MA. I need to find R. So P upon V minus MA is equal to R. Now, I'm here. So what is the power?
600.
Is it given somewhere? 600.
Oh, yeah, 600.
Say. And the velocity at this point, 8. So 600 upon 8 minus 80 into 0.5 is equal to R.
R is coming as 35 Newton.
Use the information given in 2 and your answer to 4 to show that in this situation, the resistive force R is proportional to the speed of the cyclist. Use the information given in part 2. Okay, this is the part 2. When the speed is 12, the resistive force is 48. Do you know proportionality means that R is proportional to the speed? I use O-level maths. R is proportional to V, which means R is equal to KV. So the ratio of R and V should be a constant. When the resistive force, when the object is moving at 12, the resistive force is 48. So first I tried that 48 upon 12. So it means K is equal to 4. Yes. And now in the previous calculation, when the speed is 8, the resistive force is 35. Repeated the same working. Now R is a 35 and it's 8. Can you divide it?
It is coming as 4.375.
So the two values of R are very close, and it means it is working like a constant. K is approximately constant. So R is proportional to V. A student walks from A to B along the path shown. The student takes time t to walk from A to B. The student state the quantity apart from t that must be measured in order to determine average value of speed and velocity.
The distance and displacement.
Right, distance. That's a very simple question there. And what about velocity displacement? Define acceleration.
Rate of change of velocity.
Acceleration is the rate of change of velocity. Good. A girl falls vertically onto a trampoline as shown. The trampoline consists of a central section supported by springy material. At time t is equal to the girl starts to fall. The girl hits the trampoline and rebounds vertically. The variation with time of velocity v of the girl is illustrated. Now, this sketch needs some quick review.
So at this peak, does it mean she's at the maximum height?
Um,
The
velocity is zero at maximum height when someone is jumping during a vertical motion. Suppose this is the vertical motion and the object bounces and reaches the maximum position. Velocity is zero at
okay, and velocity will be maximum when it is going to hit the ground.
So this is the case. You can see that initially the graph is going up, which shows velocity is increasing.
The girl is moving down.
Yes.
And when the velocity is zero, it is the maximum height.
When velocity is zero, this point, when velocity is zero, this is the maximum height reached. And is showing us with the rebound time. For the motion of the girl, calculate the distance fallen between 0 and when she hits the trampoline. You have to see this graph.
She hits the trampoline like around when the velocity is 8 meters.
You have to see the graph. And this is the highest velocity reached when velocity is increasing. It means it's going down. If I mark it here, it's going down. It rebounds. This looks be the position where the object hits the ground. Then it goes down, velocity is decreasing, and the object is going upward. This is zero velocity position. In other words, it is maximum height. And then it falls back. This is the maximum velocity. It's increasing. And then velocity decreases to zero. So now this is a situation. He says that the distance fallen between time t is equal to 0 and when she hits the trampoline. Now, can you tell me where she hits the trampoline? Ground means trampoline. Ground means trampoline. So she hits the ground here. Now we have to carefully see this number slightly before 1. Now, can you tell me what is this blue line? Yellow line. Is it 0.8 or 0.9 should be there? Because 0.5 to 1, there are 10 divisions.
0.9.
So I take it 0.9. So I need to find this area. I need to find this area.
So this will be a triangle.
Yes, very good. It's a triangle. And triangle is half into base into height.
Half into 0.9 into 8.8.
Yes, very good. Half into 0.9. And are you sure it's 8 or it is 8.7?
I think almost 8.8. Because there are 5 divisions and each are divided by, I think, 0.4 each make up for.
Right. So I marked it here and it's going to be 10. So it means 8.2, 8.4. No, it should be more. So let's precisely read it. That is a difference of 2. And there are 5 divisions for 2. So if there are 5 divisions for 2, then it will be 2 upon 5, 0.4. One division is 0.4. So it will be 8.8. Now solve this.
It is coming as 3.96.
3.96.
This will also
3.96.
to one significant figure.
Yes, this is a very good pick. I was going to say the same, that we should check. Graph is marked to 2 sig fig. There is no other data visible. So we can take 4.0 also. So let's take 4.0, 2 significant. The average acceleration during the rebound. Formula is F is E. One option is this. And second option is this. He has highlighted the rebound time. We should try to read the rebound time. It's starting from 0.9 and going up to going up to here. Let me join it here. Yes. So let's figure out the rebound time. It's starting from 0.9 and where it is ending. That's an important question. 1, 2. How many boxes? 1, 2, 3, 4, 5, 6, 7, 8. After 1, it is 8 box. So what
One
it should, sorry,
1.4.
1.4, 1.1, 1.2. Okay, fine. So it is so it is ending at 1.4 and starting at 0.9. So rebound time would be 1.4 minus 0.9. So it will be 0.5 second. I got the rebound time, and velocity should be carefully seen. Now, can you help me read the velocity? It is 8.8 on the top and
5.2 almost. No, 4.8. Minus 4.8.
our scale is 0.4 for one division.
So minus 4.8 because there are two divisions.
Yes. So it is minus 4.4. Now I have the data and I have the time. U is equal to 8.8. V is equal to minus 4.4. T is equal to 0.5. Acceleration formula is V minus U upon T.
Will we take minus 4.4 as minus or plus?
Definitely, we have to take it because it's a rebound. In rebound cases, acceleration is very high.
It is coming as 26.4.
Looks fine. Maybe you're getting the answer in negative because
Yes.
both numbers are negative, but would not consider it because it's an average acceleration. It's not retardation. Use figure 2.3 to compare without calculation the acceleration of the girl before and after the rebound. We can see their slopes. You can see, are they parallel, the two lines? So much work on it now that let me mark it. I'm asking about this line and asking about this line, two red arrows.
They
Are
are
the two lines parallel?
yes.
So it means gradient is the
Same.
same. So you will tell the examiner that both the lines are straight. You will say here, it's a 2-mark question. Both lines are straight and means constant gradient. Both lines are parallel. Both lines are parallel means same acceleration. Use figure 2.3 to compare without calculation the potential energy of the girl 0 till 1.85. 0 and 1.85. So he wants to compare at 0. This is the 0 position. And at 1.85, where is 1.85? I think
So
the ending position, this one.
won't the potential energy be the highest at both points?
But both the positions are at 0 velocity. 0 velocity means highest position. So don't you think that the two positions are the highest positions in the journey, but the return journey looks smaller?
So initially it will be higher and then it will be lower.
It means some energy has lost. Both are highest positions, but I think the rebound height would be less. So if suppose the girl drops from this position, but after rebound, she might have reached this position. So both the positions are showing gravitational potential energy, but even the graph is showing that the rebound is smaller. The graph is showing that the rebound is smaller. It means in the rebound, it has reached less height. The potential energy of the girl at 0 and 1.85. Explain your answer. So you will say that after rebound, the height is less. So potential energy at 1.85, this one is less than the potential energy at 0. Did you get this idea from the graph?
I got it because it's the rebound.
It's a rebound, and you can see actually so much working has already occurred, but I will try to shade it, the red one. Can you see this area is less than the orange area?
Yes, I got it.
It means red area means the rebound distance. Rebound height is less than falling height. So when rebound height is less than the fallen height, the potential energy would be less. So we did this challenging question, and this is over for today. And I will be starting yearly papers, and I will be posting them, and I will be because now the time is so less that I will message for other classes to you that whenever I'm doing you can also join as Saturday, Sunday classes. So we can do some yearly together also. Practically, as a teacher, I always prefer doing topical with students, because you know why? Because in topical, when you do 2 questions, 3 questions, this is fine, but you can actually revise some concepts also, just like we have revised this. So it's over for today. I will text you the next class, inshallah. Allah Hafiz.
Allah Hafiz.